yet another video from the topic differential equations. We have seen two methods of solving differential equations, mainly variable separable form and homogeneous differential equation. We will continue our discussion with explaining the third method. You might think, why do we need to go for a third method? There are some cases where we cannot use or even apply the methods which we have discussed before. So, to make our calculations easy, we go for a third method. All right. Sometimes we get equations of the form x into dy by dx plus 2 into y is equal to x square. It is a differential equation. But how to solve it? Any idea? These equations are of the form dy by dx plus p into y is equal to q. Alright? What is this p and q? Where p and q are functions of x, or it can be constants. These equations are of the form are called linear differential equations. I repeat, linear differential equations. And this is a standard form of linear differential equations. So, the linear differential equation dy by dx plus py is equal to q. From the name of linear, we can understand these differential equations have only first degree derivatives. As you can see, there is only dy by dx with degree 1. Now, let's see how can we solve linear differential equation. Now, let's see how can we solve the linear differential equation x into dy by dx plus 2y is equal to x square. So, our first aim is to bring the given equation to the standard form. So, for that, we need to divide the entire equation by x. So, we get dy by dx plus 2 by x into y is equal to x square by x. That is dividing by x. Alright. Now, compare it with our standard form. What is our standard form? Dy by dx plus py is equal to q. So, comparing these two equations, we can understand p is equal to 2 by x and our q is equal to x. Alright. Step is to find the integrating factor. I repeat the word integrating factor. From this, we can understand some integration we need to perform. That is, it is a function in which the ordinary differential equation can be multiplied to make the function integrable. And the integrating factor if is given by e raised to integral p dx. So, in this particular question, our integrating factor will be equal to e raised to integral p. Our p is 2 by x dx, which is equal to e raised to 2, 1 by x integral is log x, which can be written as e raised to log of x square. Then e raised to log is cancel, we get it as x square. So, the integrating factor is equal to x square. Now, next step is to find the solution of the given differential equation. How can we find? The solution is given by y into integrating factor is equal to integral q into integrating factor dx plus constant c. So this is a solution. Now for this particular question, find the solution. So our integrating factor is x square. So y into x square is equal to integral q is x into x square dx plus c, that is x square y is equal to integral x cube dx plus c. Again integrating x square y is equal to x raised to 4 by 4 plus c. And this is the solution of the given differential equation x into dy by dx plus 2y is equal to x square. Now suppose if y of 2 is equal to 1, find the particular solution of the same differential equation. Find the particular solution of the same differential equation. So we know our equation is x square y is equal to x raised to 4 by 4 plus c. So in this particular equation, put x is equal to 2 and y equal to 1. Find the value of c. So 2 square into 1 is equal to 2 raised to 4 by 4 plus c. We get 4 is equal to 16 by 4 plus c. Cancelling here 4, 4. We get c is equal to 0. So we got c as 0. Therefore, particular solution for the given differential equation is x square y is equal to x raised to 4 by 4 plus c. This was our equation, general solution. So when c is equal to 0, we get x square y is equal to x raised to 4 by 4. And this is the particular solution of the given differential equation. Now we have seen one case. Now the second case is case number 2, that is when the differential equation take the form dx by dy plus p into x is equal to q, where p and q are functions of y. That is, p and q are either it can be constants or they are functions of y. And solved as per the previous case. So the integrating factor in this case will be e raised to integral p with respect to y dy, and the solution of the differential equation is given by x into integrating factor will be equal to integral q into integrating factor into dy plus c. This is the solution of the differential equation of the form dx by dy plus px is equal to q. Let's see one problem. Cos square x into dy by dx plus y is equal to tan x, where the x ranges from 0 to pi by 2. So to find the solution, we need to first divide the entire equation by cos square x. So the equation becomes dy by dx plus 1 by cos square x y is equal to, what will be the right hand side? Tan x by cos square x. Now this can again be written as dy by dx plus, what is 1 by cos square? It is c square x. Y is equal to, again 1 by cos square will be c square x. So tan x into sec square x. Now compare it with the standard equation dy by dx plus py is equal to q. So one can understand our p will be c square x and q will be tan x into c square x. That is p is equal to c square x and q is equal to c square x into tan x. Alright. Now, next step we need to find the integrating factor. Integrating factor is given by e raised to integral p dx, which is equal to e raised to integral c square x dx. What is the integral c square x? It is tan x. So, e raised to tan x. Now, to find the solution, we have to apply the equation, that is y into integrating factor is equal to integral q into integrating factor dx plus c. So this is the solution. So substituting the values of q and integrating factor, we get y into e raised to tan x is equal to integral c square x tan x. Again, what is the integrating factor? That is e raised to tan x dx plus c. Now, if you look at the RHS, we can take this entire integral as I. So, let I is equal to integral c square x tan x into e raised to tan x dx. Now, we can give the substitution. Let t is equal to tan x. What substitution we can give? We can give t is equal to tan x. Therefore, dt will be equal to derivative of tan x is c square x dx. Alright. So, our I becomes I is equal to integral t into e raised to t dt. Why? Because c square x dx is nothing but dt. Then tan x is t and e raised to tan x will be e raised to t. So we get I is equal to integral t e raised to t. So our I is equal to integral t into e raised to t dt. Now we have to fix the first function and second function. First function u is equal to t and the v second function is equal to e raised to t using the rule I late. Inverse, logarithmic, algebraic, trigonometric, and exponential. So, as per this, exponential function has to be the second function and t has to be the first function. So, now integrating I is equal to t into integral e raised to t dt minus integral derivative of the first function, that is d by dt of t, into integral of the second function, that is integral e raised to t dt the whole dt. Now what is d by dt of t? Now what is d by dt of t? It will tends to 1 and integral of t e raised to t will be again e raised to t. So this will be equal to t into integral of e raised to t is e raised to t minus outside 1 into e raised to t, it will be integral of e raised to t dt, which is equal to t into e raised to t minus e raised to t. Now substituting, we get t equal to tan x. So tan x into e raised to tan x minus e raised to tan x. Taking e raised to tan x as common, e raised to tan x into tan x minus 1. Now substitute this value of I in our main equation. So the solution becomes y into e raised to tan x is equal to e raised to tan x into tan x minus 1 plus c, or from this y is equal to, dividing by e raised to tan x, we get tan x minus 1 plus c into e raised to minus tan x. And this is a general solution of the given differential equation. All right. Even though we have three methods to solve the differential equation, that is variable separable form, homogeneous differential equation, and linear differential equation, we can use a variable separable method to solve any kind of differential equation, which we will see in our next video. Now, let's have a summary of what we have discussed. This is a summary of linear differential equations. So we have mainly discussed the two forms, that is dy by dx plus py is equal to q and dx by dy plus px equal to q. For the first form, dy by dx plus py equal to q, where p and q are functions of x or constants, and the integrating factor is e raised to integral p dx, and the solution is given by y into integrating factor is equal to integral q into integrating factor dx plus c. And the second form, dx by dy plus px equal to q, here p and q are functions of y or constants, and the integrating factor is given by e raised to integral p dy, and the solution is given by x into integrating factor is equal to integral q into integrating factor dy plus c.
Manorama Horizon. Learning made simple.